Okay, let's talk about this lab that you have to do. It's a finite state machine that's a little more complicated than any that you've had to do so far. So the idea is that you've got this machine that you can put money in, and it will dispense water, and it's supposed to dispense water if you for 15 cents, and you can put in a nickel, a dime, or a quarter. And based on what you put in, it'll say what it'll do. And my cat is trying to knock my computer off the table here. So let's think about what our different states are. You know, what possibilities you have. So you could have no coin. So that would be a state of you don't have any money. So no coin is in the machine. You could have 5 cents in the machine. You could have 10 cents in the machine. You could have 15 cents in the machine. Now, could you have 20? Yeah, you could have 20 cents in the machine. Or you could have 25 cents in the machine. So those are all different possibilities of what you could have. So this would be, so you would have 5 cents, for instance, if you had just put a nickel in. And you could have 10 cents if you had put in a nickel and then another nickel or a dime. And you could have 15 by doing a dime and a nickel or 3 nickels and so on. So you wouldn't have 20 by having 4 nickels, because if you had 4 nickels, then on the way you would have had 15 cents and you would have gotten the water, and so that would be over. The only way you would have 20 cents is if you put in 2 dimes. And then the only way you're going to have 25 cents is if you put in a quarter. Because if you reach 15, it'll dispense the water and give change. Okay, so for if you have 5 cents, if that's what you have, so let's think about what your output would be in each case. If you have 5 cents, your output is going to be to do nothing. If you have 10 cents, your output is going to be to do nothing. If you have 15 cents, then that's exactly the amount you need for water, so this would be dispense water. And I am assuming that this is not like the machine, the Coke machine on the second floor of the physics building, which just takes my money and doesn't give me my Diet Coke. I'm assuming that when it says gives 5 cents change, it also dispenses the water. But so if you put in 20 cents, it would give 5 cents change. And I'm assuming dispense the water. And if you put in 25 cents, it would give 10 cents change. Okay, so those are the different possibilities. Now, we might be able to... Okay, my cat right now is eating the paper because this is what he does when I'm not paying attention to him. He is literally shredding the paper. I don't know if you can hear it or not. Clint? You're just gonna shred the paper? Yeah, okay. You know that's the Circuits 2 SI that I was gonna do. Alright. So let's think about these and think, are any of these states, can we combine any of these states? I don't think we actually can. Alright, so we'll have our state of, this is the 0 cents, we don't have anything. Okay, and then let's think about the different actions that we can do. The actions that we can do are we can put in a nickel, we can put in a dime, we can put in a quarter. So if we put in a nickel, we would go to this 5 cent state. If we put in a dime, we would go to the 10 cent state. And if we put in A quarter would go to the 25-cent state, and the 25-cent state, so the output on the 25-cent state is to give 10-cent change. And the output on any of these others is to do nothing. I don't know if this is coming through on the recording or not, but my cat is just sitting and just ripping this paper to shreds. 10 cents and 25 cents. Okay, now we want to think about what would happen from each of these states, do it with our different inputs. And if you notice, like the different actions that we can take are putting in no coin, 5 cents, 10 cents, or 25 cents. Okay, so if we are at the 5-cent state and we put in 5 cents, we would go here. If we're at the 5-cent state and we put in 10 cents, that gets us to the state of dispensing water. At 15 cents. So that's if we put in 10 cents. If we put in 25 cents, that doesn't really make any sense. Because if we had 25 cents, then we would have just put it in to start off with. And so that's really a don't care option. So we're just not going to put that in on our state diagram because that's a don't care. Alright, and then if we are at 10 cents and we put in 5 cents, we would go here to the dispense. If we are at 10 cents and we put in another 10 cents, that's going to put us at a state we haven't seen yet. That would be our 20-cent state, and that would be where we'd give 5 cents change. And again, it doesn't make any sense to put in 25 cents when we're at the 10-cent stage, because we could have just put in the 25 cents to start off with. Alright, and I think, let's see, what else do we have? 5 cents, so, from the dispense water state, you're always going to go back to the do nothing, and from any of the give changes, you're always going to go back to that. So that's going to be, no matter what your input is, you're going to go back to do nothing. That's always going to be your next state. Alright, so now let's code this with our variables. Alright, so let's see. Receive 5 cents, that would be AB equals 0, 1. Receive 10 cents, that's AB equals 1, 0. Receive 5 cents, that was AB equals 0, 1. AB equals 0, 1. AB equals 1, 0. This is AB equals 1, 0. And this was AB equals 1, 1. And then we have those outputs there. So I think probably best now to make a state table. So current state and next state. And we have, for our next state, we have 4 different possibilities. So we have AB is 0, 0, AB is 0, 1, AB is 1, 0, and AB is 1, 1. Now the nice thing is that our output depends only on our current state. So our current states are no coin, 5 cents, 10 cents, 15 cents, 20 cents, and 25 cents. And AB 0, 0 corresponded to nothing, no coin. AB is you inserted 5 cents. AB is you inserted 10. AB 1, 0 is you inserted 10 cents, and 1, 1 was you inserted 25 cents. And I will call these states A, B, C, D, E, and F. Okay, so if we're in state A, if we put in no coin, then we stay where we are in all cases. Do we? No, that is not true. If we put in no coin, we stay where we are for A, B, and C. But if we are in states D, E, or F, our next state is always going to be to go back to A. Okay, but if we're in state A and we receive 5 cents, then we go to state B. If we receive 10 cents, then we go to state C. And if we receive 25 cents, we go to state F. If we have 5 cents and we receive 5 cents, we go to state C because we'll have 10. If we have 5 cents and we receive 10 cents, we'll go to state D. And we have 5 cents and we receive 25 cents. Again, that doesn't really make much sense, so I'm just going to call that a don't care. 10 cents and we receive 5 cents, then we would go to state D. 10 cents and we receive 20 cents, we'd go to state E, and I'm going to call that one a don't care. And our output is U and V. So our output is do nothing and do nothing and do nothing and dispense water, and then give 5 cents change and give 10 cents change. Okay, now we need to decide, we need to assign states. So we have 1, 2, 3, 4, 5, 6 states. So that means we need 3 flip-flops. So yeah, I'll call them X, Y, Z. So this is our current state. Actually, what did the directions say? Do we need to do all this? Let's see. Because you don't have to do all this necessarily to code it. State diagram. So, alright, state diagram. So we've done that. Alright, so the next step is to do the Verilog, and so I will continue with that one later. This was just to get you the idea of how to get started, so I hope that is helpful. Oh, and by the way, you absolutely do not have to do it the same way I do. I hope many of you don't. This was just to give you an idea. You have different options. You don't have to do everything exactly the same.